Okay, this is your lesson 3 notes. The topic is factoring, if you care to write that. Okay, but everything else I write for your notes you should have down. This is a quick overview, so if there's anything that went over your head, please star it and come to class with questions. Okay, so GCF is greatest common factor. When you have binomials, a lot of times it will be GCF unless they're a perfect square, which we'll talk about later. But it's not like factoring a trinomial. You're just finding the GCF and you're writing what's left over. So I like to say GCF, write what's left. Okay? And the greatest common factor means the largest number that both of your numbers have in common, or the largest variable that both your sets of variables have in common. Okay? And greatest because that's, largest because it's the greatest. So, 24 and 54. What number do they both have in common? If you're not sure, you may just need to use your calculator and guess. So I know 6 goes into 24. 54 divided by 6 is 9. And then 24 divided by 6 is 4. Okay, so that is the largest number that goes into both of them. So 24 is 4 times 6. Okay, and if you want to break the y's down, you can. So this will be 4 y's. And then 54 is 9 times 6. And then we have 3 y's. Okay? So this is kind of the long way to do it, but hopefully you can see what's in common. That's what you're going to put as the GCF. And then what's left over, that goes on the inside of your parentheses. So let me highlight everything that's in common here. So they both have a 6. Okay? 4 and 9 have no other numbers in common because 4 is 2 times 2 and 9 is 3 times 3. So 2 and 3, they're both different. That's why 6 is the greatest common factor. And they each have 3 y's. Okay? So that means 6y to the third is the greatest common factor. And then when we write what's left, it's as if you took those 6 and the 3 y's out of both groups. So what's left is 4y and then minus 9. Okay? And so just think about if you were to distribute this back, what would you get? Okay, what would you get? 6y to the third times 4y would be 24y to the fourth. Okay, you already have a minus, but then if you try to distribute again, 6 times 9 is 54, and y to the third. Okay, so you're basically doing the opposite of distributing when you're factoring. That's really exactly what you're doing, the opposite of distributing. Okay, so let's do one more just for factoring. 51, a to the 8th, b to the 4th, and 17, a to the 3rd, b to the 5th. So what I notice about 17 is that it's prime. Therefore, I'm going to see if 17 goes into 51. And it does 3 times. Okay, so what's in common with both of them? The greatest number is going to be 17. Okay. And you can write 8 a's out if you want. But really, the trick is that the lowest number is going to be in common. So a to the 3rd, and then b to the 4th. And then 17 is going to be the GCF. Okay? So it would be as if, you may have learned it this way, it would be as if you found the GCF, 17, a to the 3rd, b to the 4th. It would be as if you divided that out of both groups. Okay? So, 17, a to the 3rd, b to the 4th is the GCF. And to find what's left, you can divide both groups, okay? Which that may actually be how you were taught it. Okay, and so this comes into our quotient rule that we just talked about. And what would be left in the first group, if I divided, would be 3 from the numbers. Then a to the 8 minus 3 would be a to the 5th. B to the 4s would cancel. Okay, then I would copy the plus. The 17s would cancel. The a to the 3rds would cancel. And b to the 5 minus 4 would be b to the 1st, or just b. Okay, so that's how I find what's left, is by dividing out. Okay, so rules for factoring when we have perfect squares. First, let's talk about what perfect squares are. Hopefully you know. 1 squared is 1, 2 squared is 4. We have 9, 16, so on and so forth. So when you have perfect squares, the rule for factoring, it's going to be a squared plus, it has to be minus difference of squares, minus b squared is going to equal a plus b times a minus b. It works every time. So you just find what the square root of a squared and b squared are, and then you just put it one with a plus and one with a minus, okay? So for 36w squared, let's square root it, and 25, let's square root it. Then one's going to get a plus and one's going to get a minus. Alright, so the square root of 36w squared is 6w, so that'll be 6w, and then 25, square root of that is 5, so this would factor to 6w plus 5, 6w minus 5, okay? And that's your difference of squares. So it really is very simple if you know the pattern. Okay, so let's talk about 4. The square root of 1 over 144, and then the square root of r to the 6th s to the 4th. One's going to get a plus, one factor will get a plus, and one factor will get a minus. Alright, so the square root of 1 over 144 is the square root of 1 over the square root of 144. Okay? Then square root of r to the 6th s to the 4th. The square root is the same thing as the 1/2 root. So if you divide them by 2, that's square rooting. So that square root would be r to the 3rd s squared. Okay? So let's put those in our factors. 1 over 12 and r to the 3rd s squared. 1 over 12 r to the 3rd s squared. Okay? That's the factor form of number 4. Alright, let's do 5 and 6 just really quick. 5, is that a difference of squares? Okay, that's actually not. There's a plus in between. So this one is not factorable because 16 and 1 don't have common numbers, and then there's only an x in one of the terms. Okay, this has to be a difference of squares to work. So if you have a plus in between some perfect squares, this will never work, because if you double distribute or rainbow and smiley face, you're not going to get what you started out with, because you started out with a plus. And there's no way to have a minus times a plus and make a plus. Alright? Alright, so let's do 6 really quickly. Okay, so we're going to square root the front, square root the back, 1 gets a plus, 1 gets a minus. Okay, just to make it as simple as possible. So the square root of 9 is 3, a to the 4th squared, so you're just taking half of it would be a squared, and square root of b squared is b. Alright, then square root of 100 is 10, square root of c squared is c. Alright, so this is just 3a squared b plus 10c times 3a squared b minus 10c. Okay? And if you are curious, you can rainbow and smiley face and see if you get what you started out with, and you should. Alright? So, for now, we are going to skip cubes. Save that for another day, so you can cross that all off. Alright, we're not going to worry about sum of cubes or difference of cubes. Okay, that's it for video 1, and then I'll make a video of the back.